All right, guys. So section 1.6 is on solving compound inequalities. A compound inequality is very similar to what we went over yesterday, but there are two new things. The first thing I need you to think about is this symbol right here, and this stands for and. All right, um, stands for and that means both things are true. Usually, and problems do not have the word in them. So maybe you say, I went to the store and I went and got gas. Those are both things that can be true. All right. Down below here, this upside down U stands for the union, and that means either are true. Okay, that's called union, where this up here, this N is the intersection. You will always see the word or for or problem. So it's either and or. How I remember this is the upside down N. If you think about and, this kind of looks like the intersection looks like an A, and or the right way you would write an A. Okay, so and or problems, very similar to yesterday. So if you take a look at number one, I don't see an or in here, so it must be a and statement. So what we're going to do is kind of like yesterday, solving inequalities. We're going to add 9, but instead we're going to add 9 to both sides, the outside and the inside. So -5 plus 9 is going to give me 4. We're going to bring down our less than x is less than 19 sign. The reason why, guys, we added 9 to all three sides of the equation is because we're trying to isolate my variable. So now when I look at this, I have two statements. I have 4 is less than x, which is less than 19. Well, Ms. Fedorsky, yesterday you taught us what to do with 1. Okay, so let's break it down into 2. So I could have x. Remember, I want my variable to be first, so since I'm flipping my variable here, I'm going to flip the sign as well. We have x is greater than 4. All right, and then we also have x has to be less than 19. When I go to graph this from this inequality right here that I rewrote the two statements so I can see what I need to graph, I know I'm going to have 0, 4, I'll have 19. Okay, my circles are going to be on 4 and 19. They're going to stay open like we talked about yesterday, and everything between 4 and 19 will be a solution. So if x is greater than 4 and if x is less than 19, if both of those are true, then that means it'll be a solution. All right, so any number between 4 and 19, I should be able to plug into this equation and it would be a solution. Now we just have to do interval notation. So the smallest number it can be, all right, is going to be 4. Does not hit because it's an open circle. The largest the number can be would be 19, and it's also a parentheses because it does not hit 19. All right, so 4 comma 19. Number 2, here's one of those or problems. So we have 4x is greater than or equal to -12, or 3 plus x is less than -7. So we need to solve these like two separate inequalities. So here I would divide both sides by 4. We're going to get x has to be greater than or equal to -3. Or I could subtract 3 on both sides, and we'll get x has to be less than -10. So what that means, I'm going to go in and graph this. We have 0, right? We have -3, would be somewhere in here. We would have -10, somewhere in there. Watch what happens here. They're saying x would be greater than or equal to -3. So if I come to -3, I would have a closed circle here, and they're saying any answer greater than -3 would make this statement true. Let's say 0. 4 times 0 is 0 greater than -12. Yes, so I verified that. Now, if x is less than -10, I would have an open circle here, and those would have to be going to the, -10. These answers would have to be going to the left. So let's say -20. 3 plus -20 would be -17. Is -17 less than -7? Yes, so I know that works as well. So now let's talk interval notation. A little different. Remember, you want to go from the furthest to the left, so the smallest to the highest. So the smallest for this solution to be would be in parentheses, right? We can do -infinity to -10, okay? Or, or, so we're going to make a union, or, okay, it's going to hit at -3 to positive infinity. So that's just letting us know that, hey, this is an or problem. So we're using a union, all right, and we're kind of reading what each statement is telling me on the graph. So that is interval notation for number 2. All right, the next few problems have blanked out on my screen, so I'm going to write them down. So number 3 should say x minus 6 is less than 5. Okay, and x minus 4 is greater than 2. So let's solve these. This first one, I'm going to add 6 both sides. So I get x has to be less than 11, and I add 4 both sides, x has to be greater than 6. So when I go in and graph this, I'm going to have my graph. All right, so I have 0 in here. I'm going to have x has to be less than 11, open circle to the left, or x has to be greater than 6. So if I have this here, open circle this way. So let's talk interval notation for this one. This one, anything from 6 to 11, right, in between here would make the statements true. They're an and problem. So the smallest my solution can be, in parentheses, because it does not hit, is 6. The largest it can be is 11 in parentheses. So that's saying it has to be in between 6 and 11, but it does not hit 6 or 11 to make the statement true because our circles are open for that one. All right, number 4, I'm going to have you guys do on your own with the graph and interval notation as well. Number 4 says negative 3x is less than negative 9, okay? And it also says negative 5x plus 1 is greater than or equal to 26. All right, so I'm going to have you guys do that one for homework. Hint, hint, remember what happens when you divide by a negative number, hint, hint. And then I'm going to have you guys also do number 5, which says 2 is greater than or equal to x minus 1, which is greater than or equal to negative 2. So I'm going to have you guys do those on your own. I want you to graph them and do the interval notation for those as well. And then I'm going to hop in down below on this next word problem. It says the sum, we know that's an answer to an addition problem, of 3 times a number. So the sum of 3 times a number and 4. So I'm just going to say 3n plus 4 is between negative 8 and 10. Remember, we've talked about between. Well, we know one's going to be negative 8 and the other is going to be 10. So we need to figure out how we can say between with our inequality signs. Well, we know negative 8 is smaller, so I always put negative 8 over here and 10 over here. Between, the symbol for that we learned yesterday were those two less than signs. Or sorry, yeah, less than signs. Okay, so it says the sum of 3 times a number and 4 is between negative 8 and 10. So we're going to go ahead and solve. I need to start by isolating the variable. So I'm going to subtract 4 both sides. We get negative 12 is less than 3n, which is less than 6. I'm going to divide both sides by 3, and we get negative 4 is less than n, which is less than 2. Have us graph this as well. So if I read this as two separate statements, n is going to be greater than negative 4, open circle to the right, okay, or n is less than 2 to the left. All right, so I know this is an and problem. So the lowest the number can be in parentheses, because it doesn't hit, is negative 4. Any of the solutions should be between negative 4 and 2, but it does not include those numbers because it does not hit those numbers. Next one, it says 5 times a number, so I'm just going to say 5x is less than 20, or keyword, okay, that tells me it's an or problem. 6 plus that same number is more than 30. All right, so let's go ahead and graph or solve each inequality. So we get x is going to be less than 4, or I'm going to subtract 6 on both sides. We get x is greater than 24. All right, so when I graph this, we get 0, we'll have 4, we'll have 24. X is less than 4, or x is greater than 24. So I know the smallest my number can be is negative infinity to 4, parentheses, or, so sorry, union, or the smallest it could be for this one, the solution's 24 to infinity. Anything from negative infinity to 4 to 3.99999 would make this statement true, and anything from 24.01 all the way to infinity would make this other statement true. Okay, so that's an or problem with graphing. This bottom section didn't copy for some reason in our notes, so I'm going to go ahead and just go over it real quick. They say name each graph. You guys are going to be great with this. So what they want you to do is take a variable. I'm going to say x, it's easiest. Write the inequality. It's going to be greater than or equal to 80. This one, x is less than negative 13. Why didn't I put less than or equal to? Because that circle is not shaded in. All right. I'm going to have you guys do this last one. So really you just have problems 4 up above and 5, which was on graphing the interval notation and solving the inequality, and this bottom one here. All right. If you have any questions, let me know.